Something entered our solar system last year. It didn't announce itself. There was no signal, no warning. One day, it simply appeared, slicing through the outer edges of space at a speed that made our fastest probes look like they were standing still. And the moment astronomers got a clear look at it, the conversations happening in observatories around the world shifted from routine to something else entirely. Its name is Comet 3 in Atlas. And what it carried with it, written in light, in chemistry, in speed, has changed the way we think about where we came from and what else might be moving through the dark between the stars. To understand why this object stopped the scientific community cold, you have to understand how rare a true interstellar visitor actually is. In all of recorded human history, thousands of years of watching the sky, we have confirmed only 3 objects that came from beyond our solar system. 3. The first was Oumuamua in 2017. The second was Comet Borisov in 2019. And now this. Each one has been stranger than the last. 3I Atlas was first caught by the Atlas Survey Telescope Network, a system built not to study comets, but to scan for asteroids that might one day threaten Earth. It was doing exactly that, sweeping the sky in the pre-dawn darkness when its sensors caught something moving at the wrong speed, in the wrong direction, on a trajectory that didn't belong to anything gravitationally bound to our sun. Within hours, astronomers worldwide were redirecting their instruments toward the same patch of sky. Within days, the verdict was unanimous. This object was not from here. So what exactly is Comet 3E Atlas? At its core, it is a comet, a body of ancient ice and rock that, as it fell toward the sun, began heating up, releasing a vast cloud of gas and dust that stretched millions of kilometers behind it. That tail is essentially a chemical exhaust trail, a signature written in light, readable by any telescope powerful enough to look. And what astronomers read in that signature was extraordinary. The object is estimated to be over 7 billion years old. Our sun is roughly 4.5 billion years old. The Earth is 4.5 billion years old. 3I Atlas predates both by more than 2.5 billion years. It formed before our solar system existed, inside a completely different stellar environment, in a region of the galaxy we have never visited and may never reach. It is the oldest object humanity has ever had the chance to directly study in our own cosmic neighborhood. A relic from a time before our world had any reason to exist. And then there is the chemistry. And this is where the story takes a genuinely strange turn. When scientists analyzed what 3I Atlas was releasing as it heated up near the sun, they found something that violated every pattern they expected to see. The comet was releasing nickel, measurable, significant levels of nickel vapor streaming off its surface. Now, nickel in a comet is unusual on its own, but here is the detail that made researchers pause. There was no corresponding iron. In every comet and asteroid we have studied within our own solar system, nickel and iron appear together. They are chemical companions, almost always found inside the same mineral structures, almost always released in tandem. The ratio between them is one of the most consistent patterns in planetary science. 3I Atlas broke that pattern completely. No iron, just nickel, streaming from the surface of an object older than our sun, arriving from a direction in the galaxy where no known star system currently sits. Does it have a natural explanation? Almost certainly yes. Different formation conditions, a different stellar chemistry, billions of years of isolation. But the honest scientific answer is, we don't fully know yet. And in science, Not fully knowing is exactly where the most important questions live. Then there is the speed. 3. Atlas wasn't just moving fast, it was moving at a velocity that placed it among the fastest large natural objects ever observed, passing through our solar system. That kind of speed tells a story. It suggests this object wasn't drifting gently through the interstellar medium. Something, possibly a gravitational interaction with a massive body hundreds of millions of years ago, launched it onto a high-velocity path across the galaxy. It has been traveling that way ever since, through the void, through the dark, through billions of years of silence, and by some improbable geometry of the cosmos, its path carried it through here. Now we need to address the question that has been floating around the edges of this story since the first data came in. Could it be artificial? This is not a fringe idea from the corners of the internet. It was raised publicly by Loeb, a Harvard astrophysicist, one of the most credentialed voices in the field, who has consistently argued that anomalous interstellar objects deserve open-minded scientific scrutiny, not premature conclusions. His position is not that 3I Atlas is alien technology. His position is that we should not assume it isn't before doing the work to rule it out. The unusual chemistry, the velocity profile, the departure from known patterns. These, he argues, are precisely the kinds of anomalies that warrant serious investigation. Major space agencies, including ESA and NASA, have classified 3I Atlas as a natural comet. Unusual, ancient, fast, but natural. And the scientific consensus strongly supports that conclusion. Natural processes across billions of years of galactic history can produce extraordinary things. But the fact that the question was asked at all by serious scientists with real data in hand marks something genuinely new. For the first time in history, we are not speculating. We are measuring. We are analyzing actual light, actual chemistry, from an actual object that traveled here, from somewhere else entirely. That is a threshold humanity has never stood on before. Here is what often gets lost in the excitement over the exotic details. Tracking 3I Atlas was not just scientifically beautiful, it was a rehearsal. When this object was first detected, it was still far enough out that scientists had weeks to coordinate, prepare, and point instruments toward it. That gave us something enormously valuable: time to practice what a real planetary defense scenario would look like if the incoming object were a threat rather than a wonder. And some of the earliest detection data came not from ground-based telescopes, but from ESA's JUICE spacecraft, a deep space mission designed to study Jupiter's moons. As it cruised through space, it happened to be in the right position to catch something Earth's telescopes hadn't yet flagged. This is the argument planetary defense experts have been making for years. The more eyes we place in deep space, the earlier we see things coming. The earlier we see things coming, the more options we have. 3I Atlas proved that argument with a real object, in real time. Right now, 3I Atlas is on its way out. It has rounded the sun and is accelerating back into the interstellar void, carrying with it whatever it has not yet given up. In years, it will be beyond any telescope we have. In centuries, beyond the nearest stars. And in billions of years, if it survives, it will still be out there somewhere in the dark between galaxies, ancient beyond all reckoning, bearing no record of the small blue world it briefly passed. We had one window, one chance, 7 billion years of travel, older than the sun, older than the Earth, made of elements arranged in patterns we don't fully understand, moving at speeds that still give researchers pause. Whatever it truly is, wherever it was truly made, it came here. We saw it. We measured it. We learned from it. And somewhere in the data it left behind, there may be answers to questions we haven't even learned to ask yet. The universe doesn't knock very often, but sometimes, just sometimes, it lets itself in.